All right, welcome everyone to the latest virtual office hours session. Today's topic I wanted to leave deliberately open-ended because there's nothing, at least in California right now, especially extreme or alarming going on. So in this calmer window, I wanted to open up the floor to a wider range of questions than usual. And so I did have a few things that folks sent in before the session began, and so I have those in my head. I will probably start with questions that show up in the chat, just so we get through them. But yeah, this one there's no overarching theme to today, so it's very much in the Ask Me Anything style. One thing I did want to mention, just topically, before we get started with that, is that one of the big weather headlines around North America in recent days has been the very large wildfires really extending from northern British Columbia eastward to central Saskatchewan in Canada. So west and west central Canada. These fires are occurring primarily in the boreal forests and outside of the mountainous zones. So these are not the kinds of fires that we see later in the summer in the mountains of BC and Alberta. These are occurring in very dense but relatively flat forested areas east of the Canadian Rockies. And in some of these places, especially in Alberta, the spring actually is the peak of fire season. So the seasonality is not so surprising as the magnitude of what's occurring. We've seen this in California in recent years, where, of course, fires often peak in late summer and autumn, and that's when we've seen record-breaking fire activity, even by local standards at that time of year. Well, this is a similar situation up in Canada, where the acreage burned so far this season is now greater than all total calendar years except for one since the 1950s. So we're very much on pace, it appears at this point, to break all modern records up there in terms of the severity of this fire season. And of course, the acreage burn doesn't tell the whole story in terms of the ecological and societal impacts of fire. Unfortunately, this is a case where the very large acreage burn total does actually correlate with a high proportion of high-intensity fire that is primarily causing harm both to people whose homes have burned, many more millions of people who have been suffering through terrible air quality. In fact, this is degrading air quality all the way from the Northwest Territories of Canada to the Midwestern U.S. So everywhere from Chicago to Denver to Alberta and points north and east have been really severely affected by the smoke from these fires. And also ecologically, these are systems that are, of course, fire adapted, much like California's ecosystems are, but we're operating outside of the range of frequency and intensity that these systems are used to. And so there's a lot of carbon being emitted by these fires. Unfortunately, they're burning again in old growth coniferous forests in the boreal forest zone, and also in peatlands, which is not so much a problem from a dangerous wildfire in terms of burning your house down, but it can produce massive carbon emissions and cause air pollution issues that go on for many months, because in the peatlands, even if you get a heavy rain event, that's going to likely to continue smoldering and burning for the rest of the season in those areas. So although it's not California related, it is wildfire related, and it is affecting much of North America and has been in the news. So I did want to contextualize that. Canada may be in for a rough fire season in general. Of course, as I mentioned, it peaks east of the Canadian Rockies in Alberta right around this time of year in the spring, but it's also been very dry and warm recently in the interior of British Columbia. It isn't yet dry enough there to sustain widespread wildfire activity, but we'll probably get there this summer unless conditions change. So Western Canada, the far western part of Canada, including the mountains of BC and Alberta, might get in on this later in the season, and that might affect California more directly because it could be a source of smoke later in the season even if California fires aren't active, you could get long-range smoke transport, much as we are in the central of the country right now from Canada. So something to keep in mind, a globally significant event, partly because these fires are also injecting a very large amount of smoke into the upper atmosphere through pyrocumulonimbus events. So these are huge fire thunderstorm clouds that inject smoke all the way up, occasionally into the stratosphere, where the smoke lasts much longer than it would if it remained in the lower troposphere and eventually fell out or rained out. If it gets up into the stratosphere, it has a greater potential to affect regional and global climate, and in fact there's some interesting work out of NCAR, the National Center for Atmospheric Research, suggesting that the extraordinary fires in Australia back in 2020, the record-breaking ones that again injected a huge amount of smoke into the stratosphere through pyrocumulonimbus events, these fire thunderstorm events, may have been at least partially responsible for the prolonged strong La Nina event that affected California, among many other places, over the past few years. So these events can affect global climate. We're only just beginning to understand exactly how, but these are influential, events at global scale sometimes, and so I think it's interesting to talk about in that context. So don't want to spend too much time on that, but thought it was interesting. Let's see. There's a few questions coming in, so I'm going to start going down the list of questions. I'll keep looking at them as they come in, and then as I mentioned, I've got a couple in mind from earlier that people passed along. Question from Haley about the big melt, the term given to the fact that there has been a very large amount of snow and snow water equivalent up in the Sierra Nevada, especially this year in California, a record amount in the southern Sierra at least, not quite record amount in the central and northern Sierra, but in the southern Sierra certainly, and the notion that all of that, of course, must eventually melt and come downhill. And I will say that, at this point, we've gotten relatively lucky. So far, we've threaded that needle. There's been a lot of water coming downhill, but it has not all come downhill at once. And so the level of flooding in the Sierra Nevada rivers and streams themselves has been pretty minor to moderate. But downstream, of course, where the water accumulates in the Central Valley, it's been a bit of a different story down in the Tulare Lake Basin, and now increasingly in some other places in the San Joaquin Valley, a bit farther to the north, where there is some growing flooding, and the risk in the Tulare Lake Basin remains very high and is going to continue to increase. So we've seen, as you'd expect, pulses of enhanced melt and localized flooding. So, for example, the Merced River in Yosemite has reached flood stage a couple of times. Only just, though. These are not destructive floods in Yosemite. They're just a river reaching or slightly exceeding bankful. But all of that water is, when it reaches the valley, particularly in the Tulare Lake Basin, which is, again, a basin without an outlet, the water accumulates, and the extent of flooding just continuously increases over time while there's still large amounts of water flowing into the system. So we've gotten lucky so far. We did not get, at least we haven't had so far, and there's nothing on the horizon, any late season atmospheric river warm rain events, so that's good. That would have been a big problem. We haven't seen that. I'm somewhat more confident that maybe we won't this season at this point. They have happened in June before, though, so I wouldn't totally count that out, but I think it's maybe less than a 20% chance at this point. We have had some significant heat waves, but they haven't been super prolonged. So there have been some individual days where there's been really warm temperatures at the high elevation snowpack with a big melt pulse, but we haven't had a really searing heat wave that's lasted for days or weeks. And so the rate of accumulated melt has spiked briefly, but not for a prolonged period. So that has also been relatively favorable for preventing major flooding on the rivers leading into the San Joaquin Valley. And so we've kind of threaded that needle that I was saying. The best case scenario was that we sort of did thread that needle. I mean, there's a huge amount of water. It's got to come downhill. There's going to be problems in Tulare Lake Basin no matter what. But elsewhere, the situation was largely dependent on how quickly the water comes downhill. So far, we've gotten relatively lucky with that. The flip side to that coin, though, is because we haven't melted this really fast, there is still a huge amount of water up there. And I think folks may be forgetting this because at low to middle elevation, the snow is largely gone. But at high elevations, where the vast majority of that actual snow water equivalent is, there's still huge snowpacks. They're still clearing roads in the high Sierra right now that have 20 to 30 feet of snow on them at 8, 9, 10,000 feet. So again, not a lot of roads up at that level, but huge amount of snow still and a lot of snow water equivalent. And so there's actually some flood watches in effect right now, newly for the Sierra Crest and eastward, because of afternoon thunderstorms that are occurring in addition to relatively warm temperatures. So the combination of snowmelt and localized isolated downpours from these thunderstorms might lead to an increased risk of flooding from about the Tahoe Basin eastward. So this is slightly less of an issue for the western slopes, more an issue for the crest and eastward. But this is another little mechanism where there might be some additional flooding coming in the next few days because of these spring thunderstorms, which normally wouldn't cause a flood threat at all. But if one of them happens to sit over a small to medium-sized watershed where there's already a lot of snowmelt going, that actually could cause some problems. So there's that kind of concern right now. It would be great if we don't get any really late season atmospheric rivers, say in June, and if there aren't any really prolonged heat waves in June. And if that's the case, maybe we make our way through this without any really terrible flooding, despite the big melt, because the big melt was spread out over a few months rather than happening, as has been the concern, over like a 1 to 2 week period at some point. I don't think we're out of the woods yet because there's still enough water up there because it's melted relatively slowly that could still happen if we get an exceptional heat wave or a late season atmospheric river event at any point in the next month. That's still going to be a risk. And even if that doesn't happen and we get lucky with this continued relatively gradual melt, there's probably still going to be the risk of major flooding in and near Tulare Lake Basin and similar regions. So there's still major concern about Corcoran and some of these towns that are literally within this basin. So agricultural land in that area is going to be flooded for months, and there's still significant risk to populated areas in parts of the San Joaquin Valley for the next few weeks at least, and probably for the next couple of months. So not out of the woods yet. The big melt is still ongoing, but it isn't as rapid as it could have been had weather conditions played out differently so far. So there's still enough water up there that could change, but there's no immediate indication that it is going to change. So on that front, I would say that no news is relatively good news at this point, unless a unexpected weather event comes our way. And there could still be localized flooding from the combination of snowmelt and some isolated thunderstorm downpours up in the mountains in the coming days. So that's the big melt update. Folks commenting from different parts of the West that there is tons of smoke. Again, almost all of this is coming from Canada, from the big wildfires in the boreal forests, mainly in Alberta, but also east, central sort of Canada into Saskatchewan, and also west into the interior northern parts of British Columbia. Still east, everything happening is essentially east of the Canadian Rockies, but the Canadian Rockies bend, they sort of arc northwestward rather than being north-south aligned as they are in the U.S. They sort of have a southeast to northwest kind of extent up in Canada. So all of this is occurring from the relatively flat forested areas, and that smoke is really getting blown south and eastward primarily, but some of it is leaking westward, it sounds like, into the Snake River Plain up in Idaho, certainly into Utah, and then east of the American Rockies, so from central Montana and then eastern Wyoming and Colorado eastward. There's smoke, observable all the way from Denver to New York City and maybe into Europe at times from these fires. So again, it's a big deal. Question from Bill about smoke, Bill in Montana, about whether wildfire smokes can keep low temperatures at night warmer than they would be without smoke. This depends on the concentration of smoke and what level of the atmosphere it's at, but generally the answer is yes. It tends to keep overnight temperatures warmer and then daytime temperatures colder, because of course it sort of acts like an insulating layer. It prevents the Earth's energy from escaping at night, keeps it in the boundary layer, but it also prevents the sun's energy during the daytime, in a lot of cases, if it's dense enough, from reaching the surface. So the days are cooler. So there's a narrower diurnal range, but on average, probably slightly cooler than it would have been without the presence of smoke. California has certainly seen that in recent years. During some of these smoke storm days, it's actually been like cold and clammy under the smoke layer, even in the wake of like record-breaking heat waves. These fires pop up, reach extreme intensity, and then block out the sun for a couple of days. That is a process that unfortunately many people have experienced. Most people probably at some point in the West in recent years. So, smoke does affect the weather, both locally, regionally, and if you can inject it high enough into the atmosphere, globally. So, and this is something that is not always well captured by weather models and climate models. So this is a gap in some of these predictive systems, and it can result in unpredicted outcomes on all the way from daily temperature predictions all the way up to seasonal and annual climate outlooks. So, something to think about. A question about thoughts on upwelling and coastal fog in Monterey Bay Area. I'll extend it to California generally with El Nino. This is a tricky one because there's a lot of variability in terms of how the California nearshore environment responds to El Nino. In some years it doesn't seem to do much. It usually does something in the extreme years though, and it does look like we're headed for a strong to very strong El Nino event most likely this year. So assuming that happens, which is somewhat conditional, I would eventually expect that the nearshore temperatures would warm up, especially in Southern California and also to a lesser extent in Central California, perhaps not so much off of Northern California coast. So Monterey Bay is usually more Central California, but it's still kind of on the boundary of that, where it may or may not see significant warming. Certainly not in the next month or two. It's going to be cold. Temperatures have warmed though, not because of El Nino, but because of the lack of northwesterly flow. So we've been talking in recent weeks about how unusually cold the nearshore ocean temperatures have been. They're much less so today. In fact, there's now an area of warmer than average water just off the coast. There's a very narrow band of near to slightly below average temperatures still right along the coast, but even 30 or 40 miles offshore now is a big region of warmer than average conditions. So we have gotten rid of a big part of that cold water pool, at least the unusually cold water pool off the coast of California. It might make it a little bit easier for a coastally trapped Kelvin wave to propagate up and really kill off upwelling again at some point this summer. So I do think there will be some anomalous ocean warmth by late summer, especially in Southern California, so LA, San Diego, Santa Barbara. Then again, maybe up through the Central Coast. So Monterey Bay is kind of a wild card. The challenge is California's nearshore ocean temperatures, especially the northern 2/3 of the coastline, so really everything north of about Santa Barbara, where the coastline sort of turns from being east-west oriented to northwest-southeast oriented, sort of. Point Conception, I believe, essentially be marking the primary turning point. North of that point, the water temperatures are really dominated by the vertical circulation of the ocean, so from cold water coming up from beneath. Rather than what's happening so much at the surface with surface currents, it really matters how much cold water is upwelling from the deep ocean. And year to year, there's a functionally infinite volume of cold water in the deep ocean that does not go away suddenly. So really, the only way to get very much warmer than usual temperatures off the coast of Northern California is to either reduce or eliminate that upwelling. So it's actually a question not so much of can you get warm ocean currents moving warm water into the region. That's not really how that works. It's more a question of can something shut down that persistent northwesterly wind flow that actually causes water to surface currents to flow offshore. This is, I don't necessarily want to get into an oceanography lesson, but this is known as Ekman pumping, where the direction of the surface currents induced by winds are not parallel to the direction of the wind. This is essentially has to do with the Coriolis effect. But in the case of California, it means that water is pushed back offshore, and it sets up a vertical ocean circulation. This is why there's the water near the Farallon Islands is so darn cold. It's colder than the water at that latitude almost anywhere else on Earth. It's a very cold ocean. But it's not magic. It's just because the water is moving vertically upward from very deep levels where the water is inherently very cold because there's essentially no sunlight reaching the deep ocean. So it doesn't matter how hot the air is up on top of the ocean if you're getting water from hundreds of meters down that just isn't really getting affected by that sunlight. So it's a long way of saying I'm not so sure about Monterey Bay specifically, but by late summer and autumn, I would expect that water temperatures off the coast of Southern California will be warmer than average and perhaps extending up into at least Central California as well, if we get a couple of coastally trapped Kelvin waves, or if we can get the subtropical high this summer to set up at least briefly in a place where it's not going to give us a lot of upwelling. But for the next month or two, I think May gray and June gloom are probably going to be the name of the game, as you would expect in May and June in coastal areas in California. That's not unusual. That's to be expected, really, this time of year. And I suppose this is a good time to bring up one of the other questions that I had posed to me before the session started, which is, we talk often about El Nino and its relationship to California winter precipitation, but what about summer and autumn? And the answer is, in summer, honestly, there isn't really a very strong relationship between El Nino and what we see. Historically, there was actually a weak relationship between El Nino and slightly cooler summers across most of California, though I was actually just checking the numbers this morning, and the long-term warming trend due to climate change essentially overwhelms the magnitude of the typical very slight cooling effect in summer from El Nino. So if you add those two things together, a fairly robust long-term warming trend and maybe a very weak signal for slightly cooler than average temperatures from an El Nino event this summer, we still, come to a prediction of, on average, above average temperatures relative to the 20th century, but perhaps slightly less so than what otherwise have been the case. It doesn't really tell us that much about impacts, because it still means the summer is more likely to be warmer than most of the summers in the 20th century because of the long-term warming trend, and it doesn't really tell us anything about individual extreme heat waves either. You can still get a relatively cool summer, and if it's punctuated by extreme heat waves, those are the things you remember, because that's where the societal and environmental and wildfire-related impacts come from. So, but there's not a really strong signal in the summer, generally speaking, in terms of temperature or precipitation in California. And that's partly because El Nino events usually don't reach peak strength until later anyway, but it's also because the features that are most important for California summer weather aren't directly affected by El Nino as some of the things that are important in winter. So the subtropical high, the semi-permanent feature in summer off the coast of California, is pretty much there, El Nino or not. And that's what gives us the northwesterly flow most of the time, that cold water upwelling along the coast, and sets up that strong temperature differential between the hot inland valleys and the cool coast with the marine layer, the sea breezes and stuff like that, the typical summer stuff. But in winter, we don't have that subtropical high. That gets suppressed southward, and we're more influenced by the depth and center of the Aleutian low, that semi-permanent low pressure system that expands and deepens in winter. In a strong El Nino event, that tends to deepen a lot more and extend further southeastward. So that really does influence California in winter to a greater extent than anything influences California climate in summer. So there's a non-linearity there. That we would expect stronger winter impacts than summer impacts generally. The autumn is kind of a transition between these things. As I mentioned, there is a slight tilt towards warmer than average ocean temperatures in autumn, so you might get somewhat warmer coastal areas in autumn. And indirectly, especially during a strong El Nino event, especially during a strong east-based El Nino event where the water temperatures off the coast of Baja California get warmer than usual, there would probably be a slightly increased likelihood of autumn precipitation from remnant tropical cyclones. So it's a weak signal. There's a lot of randomness embedded in it. But I would think that there's a somewhat increased chance of remnant moisture or circulations from tropical storms or hurricanes in the East Pacific creating interesting weather in California from about August through October or so during a strong El Nino event. So it won't happen every year. It won't happen during every strong El Nino, but I do think it tilts the odds in favor of those sorts of events from August through October. Of course, exactly what that means on the ground depends on a lot of things. It doesn't necessarily mean it's going to be wet in the autumn. It could bring a significant early season precipitation event, which is always, it's welcome from a wildfire perspective. Or it could bring a big dry lightning event right at peak dryness season if there's just enough moisture to create the thunderstorms, but not enough really to rain significantly at ground level. That can also happen. So blessing or curse really depends on the context, but it does probably slightly increase the odds of at least one of those things happening this fall. But what it actually means in practical terms will depend very much on if it happens, if there's a lot of rain associated with it, or whether it's mainly drier thunderstorms. It's impossible to say. It's only a modest tilt in the odds, but really it's not until winter that there's a stronger at least, seasonal signal between connecting El Nino and conditions we'd expect to see. So in other words, in summer, I don't think it's going to be hugely influential, somewhat more so in autumn, and then if we do get a strong event, then perhaps quite influential in winter, when during a strong event, despite claims to the contrary, there's still strong evidence to suggest that a major east-based El Nino event, or even a major Central Pacific El Nino event, honestly, would increase the likelihood of wet conditions, or even very wet conditions in Central and Southern California during the winter. So that's still the expectation for what would be the seasonal prediction, assuming we do have a strong El Nino event in place come September or October, which appears increasingly likely. Let's see. Interesting question. So the question is, if the Pacific Northwest heat wave from 2021 were to be further south, like in Death Valley, could there be a new world record hot temperature? Well, that's an interesting question. And I don't think we can quite visualize that exact pattern, moving 1,000 miles to the south over a hotter area, because that kind of pattern wouldn't be very likely to occur, as it did in a hotter place. There's sort of a reason why this appears to be a preferred location for those sorts of extreme blocking ridges in early summer. But I guess I understand what you're getting at. I think it's a good question. And the answer is, yeah, I think in a warming climate we will eventually see new world record high temperatures. One challenge is that a lot of the hottest places on Earth don't have good temperature records. In fact, I'm quite certain there have been places on Earth that have been historically, perhaps for 100 years or longer, hotter than the officially observed highest temperature on record, which is 130 degrees Fahrenheit in Death Valley. So there probably are places that have already been hotter than that, in remote desert areas of either perhaps some corner of Death Valley we haven't measured yet, or some remote corner of the Sahara, on the northwestern fringe where it gets ridiculously hot. Something like that. They're probably, or maybe the interior of Saudi Arabia somewhere, in the middle of the sandy desert where no one really has a thermometer. One of those places has probably already been hotter than 130 degrees, but no one's, if a tree falls in the forest and no one's there to see it, kind of situation. But yes, whatever the hottest maximum is today, which is probably higher than 130, we'll probably experience even hotter temperatures in a warming climate. But there's an interesting constraint, which is that the way the climate is warming, it doesn't there are some meteorological constraints on how extremely hot temperatures can get. So I would expect that the increase in the typical annual average world maximum temperature at any given location, for example, will probably increase more slowly than other kinds of temperatures. So we already know, for example, that nighttime temperatures are warming faster than daytime temperatures. So I think that, yes, it'll nominally inch upward, the global record maximum high temperatures, but it's the other temperatures that we actually experience more commonly that'll probably increase at a much faster rate than the most extreme extremes, just because of the nonlinearities are involved. It's pretty difficult for the surface to get that hot. You need the right soil conditions. Essentially, you have to have conditions where there's no moisture. So all the places I mentioned are places where it's, deserts can be quite vibrant and full of vegetation in some places. What you need to get 130 plus degree temperatures, you really just need bare sand or dirt or something with essentially no vegetation and almost no capacity to have any moisture in the surface soil at all. You pretty much need to be in a place that has a ground that's just going to absorb all the solar radiation. You need a huge amount of solar radiation coming in, perfectly clear skies, and you need an atmosphere that somehow traps all that heat in the boundary layer. So you need some situation where it doesn't just distribute that heat over a really deep layer of the lower atmosphere, but it needs to be trapped right near the surface. So there's a pretty specific set of conditions that are required for that level of extreme heat, and I do think we'll eventually, as the climate warms, we will set a new world record high temperature. There's a good chance it's going to be in Death Valley, just because it's probably the hottest place in the world where we currently have a reliable thermometer in place. So my guess is some year we'll hit 131 or 132 in Death Valley, and that'll be the new world record. But, this is probably also happening in the interior of Saudi Arabia and in the Sahara Desert, and, maybe other places that I'm not even thinking about, that we just don't have good instrumentation, which is sort of an interesting reflection on that. For all we know about the world, there's a lot of data voids still. There's a lot we don't know, even about what's happening, day to day now, not let alone what happened 50 to 100 years ago. So, more data would be helpful, but as it turns out, the world record temperatures, it's kind of a novelty. Honestly, it's not a hugely meaningful indicator of anything in aggregate. But it's an interesting novelty, and boy, 130 degrees is awfully hot. So, if you want to be in the place where the next time that the world record is set, your best odds are probably to go to Death Valley during a very intense heat wave. So again, if you do that, be careful. But it is doable. People do go and stand in front of the thermometer at the Death Valley Visitor Center, which is fortunately air conditioned. Let's see what else is going on here. What else do we have on the list? Yeah, Jennifer Roberts mentions that Donner Summit still has 8+ feet of snow on the ground, and even more than that, it's not 8+ feet of fresh powder, it's 8+ feet of accumulated very wet cement that has compressed into almost ice. So there's a lot of water in that 8+ feet at Donner Summit, and in similar elevations, probably more than 8+ feet at similar elevations in the Southern Sierra. So a lot of water up there still. Big melt is not over yet. A question from George about the connection between El Nino and increased Sierra precipitation specifically. Again, as I've talked about before, I hate it professionally when folks actually do these linear correlations between the Nino 3.4 ocean temperatures and precipitation in California. It's just not a meaningful metric, because the relationship is nonlinear. We know this should be true from a physical science perspective, and we know that it appears to be true in observations, in the sense that for weak to moderate El Nino and La Nina events, there just isn't much of a relationship. But for the very strong ones, there is. And we know this not just by using the historical record, where there's a pretty small sample size of like a low single-digit number of events on both sides. You can't get a statistically meaningful sample size from that necessarily, but we can extend that sample by looking at the paleoclimate record and using climate models. And when we do that, we see that the historical sample size that we've got is reasonable representation of what we would actually expect, which is to say, for these strong El Nino events, there is a consistent signal. Generally speaking, it's not 100%, it doesn't work every year, but in general, Central and Southern California are considerably wetter during strong El Nino events, especially when they're based especially when it's quite warm in the easternmost part of the basin. And so if we get a strong El Nino event this winter that's warm in the eastern part of the basin, which now appears to be the single most likely outcome for this winter, yes, my prediction is going to be that there's a significantly elevated chance of wetter than average conditions from about the central or southern Sierra southward. The signal is not as strong in the northern third of California or so, but it is pretty strong for the southern 2/3 of the state, approximately. In the really strong events, honestly, that relationship sometimes extends all the way up to the Oregon border, but that's a little bit less clear. But for southern and central California, which does include the southern third or southern half of the Sierra Nevada or so, then yes, I would expect to see another wet winter if this transpires, most likely. Again, there are other wild cards. Could be another huge volcanic eruption. Maybe these boreal forest fires will alter global climate again this year. And these are real uncertainties. These are the kinds of things that can disrupt. So if a strong El Nino were the only thing present, then that pretty much would be the outcome. The reason why there's some uncertainty is that, we probably will have a strong El Nino, but there could also be other big things happening that either we don't know about yet or we don't have a good handle on even at the time. And so that's where this is probably what will happen, but there's no guarantee comes from, because the no guarantee part is, okay, what else is happening in the system at the time? And that part is not as predictable as the El Nino component. So that would be my 2 cents right now. For what it's worth, the very long-range extended climate ocean models are suggesting much wetter than average winter across most of California next year. That's almost entirely the strong El Nino signal, though, because these models are predicting a strong east-based El Nino for the most part. So, assuming that's true, then yes, this most likely is what would happen. But there could be other things that are important that these models are missing or not capturing yet, and that is where the uncertainty comes from at this point. Perhaps El Nino could be weaker than expected too, and that wouldn't exert a very strong influence, although I'm more confident that we will get a strong El Nino event than I am about the precipitation teleconnection, simply because we could have that strong El Nino, but something else could come along and disrupt that teleconnection. So at this time, we're sort of in wait and see mode, but that's what I'm thinking right now. Question from Trevor about whether in a warming climate with more precipitation, could the increase in snowfall help rebuild glaciers? It's a good question, because glaciers really integrate glaciers grow when there's net more accumulation of ice through a combination of cold temperatures and high precipitation than there is melting year to year. So if you have obviously more ice accumulation in a given year than you have melting, then the glacier grows. Unfortunately, the answer is very likely no. It's expected that all of California's glaciers will probably disappear in the next couple of decades, because even though the highest elevations may even see more precipitation some of the time, especially in winter, the overall warming effect just kind of overwhelms that in the long run. So even this year, for example, it's unlikely that there'll be net growth even for a year in California's major glaciers, despite the heavy snow and ice accumulation that occurred this past winter. That's just sort of, unfortunately, that's what the balance looks like. This is true really on most glaciers globally. The temperature effect is just overwhelming whatever precipitation effects there might be. One difference might be, the center of the Greenland ice sheet or something, or the center of the Antarctic ice sheet, which, as these places see much more warm atmospheric rivers in a warming climate, warm is of course a relative term when you're talking about the top of the Greenland ice sheet or the center of Antarctica, and so it's still falling as snow in a lot of places. And even if it's not, even if very occasionally this falls as rain, it's not really melting Antarctica, it's really just solidifying as additional ice. And so you can actually get net ice accumulation at the center of the glacial fields, even as the margins melt increasingly rapidly in a warming climate. The net effect is still to have net ice loss and net sea level rise from that ice loss, because unfortunately, again, the rate of melting at the coastal margins is way higher than the rate of accumulation at the center. But in fact, depending on how that goes, in some places, the more weight you put in the center of the ice sheets through this additional precipitation, the faster it flows towards the warm coast where everything is melting. So interesting coupled climate, weather, ice dynamics we could talk about. Usually not something we talk about in California. There are, of course, no coastal ice sheets in California. We just have a couple of very small mountain glaciers remaining that probably won't stick around for too long. And this is true in California all the way up into the Pacific Northwest, where a lot of the glaciers are on their way out. Probably just a matter of time due to warming temperatures there. But there's a bit of a slightly different story of the high latitude, high elevation glaciers on the ice sheets that have somewhat more complex dynamics. A couple of folks have asked about the topographic map behind me. That's actually a map of Colorado. In fact, I think the part of it that you see on the screen right now is essentially the western half from the Front Range foothills westward over the Continental Divide. So that's why it looks a little rectangular. Yeah, lots of folks commenting about how much snow is still left in the High Sierra. So I think this is an important realization for some folks at lower elevations. Like, oh yeah, it's been warm and I don't see any more snow. That may be true where you are, but up at high elevations, there's just a massive amount remaining still. Let's see what else we go here. I'm just going down the list, make sure I know what has come in before I start responding here to the latecomers to the conversation. Question from George about temperatures and strong El Nino and the snow line in the mountains. It's a good one. Again, historically, stronger El Nino events were actually associated with slightly cooler than average winter temperatures. Of course, once again, the problem is that the long-term warming trend has exceeded the degree to which El Nino would historically cool winter temperatures. So I still think that the net effect will probably be, I don't think this winter is likely to be a really warm one in California. It may be near to slightly below average, but less, what is an average winter anymore? I mean, it's become harder to define. So it'll probably be cold enough for good snow accumulation. I would say that. It doesn't look like it's going to be an exceptionally warm winter if we get a strong El Nino event, since there is a relative cooling effect slightly from El Nino during winter in California, due to the, this is of course not due to the warmth from El Nino itself or anything. This is due to the extension of the Pacific storm tracks. Essentially, it means that California has fewer dry spells, and so there's more unsettled conditions more of the time. That keeps temperatures down, generally speaking, in the historical period. But of course, there's a long-term warming trend, so it will probably be not as cool as previous strong El Ninos, but probably also not as cool, not as warm as it might have been in the absence of a strong El Nino event. So how's that for a head? I don't think it would be warm enough to seriously interfere with snow accumulation in the mountains. So if you get a wet winter, you're likely to have a pretty good snowpack from that precipitation in a strong El Nino year, at least in the southern and maybe central Sierra. Again, northern Sierra is a bit different. It's lower and it's a little bit farther away geographically from the strong El Nino most dominant teleconnection. A comment from John about the Italy flooding. Yeah, some folks may realize there's been another set of extreme events with catastrophic flooding in parts of Italy immediately following a catastrophic drought. In some places in Italy saw, I believe, half a year to a year's worth of rainfall in a day or two. Again, we just keep seeing these events with greater and greater frequency, these record-breaking precipitation events, and these huge swings between opposite ends of the hydroclimate spectrum. This is that precipitation and this hydroclimate whiplash that I keep mentioning. It's not isolated to California. In fact, this summer we're going to be working on a review piece about global hydroclimate whiplash in a warming climate. So that'll take a while before it comes out into the public view. But I have some great colleagues lined up to help out with that. So that's something we'll be working on later this summer. Hopefully we can tie it into the the University of California Climate Action Initiative. We have a proposal pending there. I guess we'll find out later this summer whether that gets funded. So that'll be something that would be very California centric, even though one of the underlying analyses would be global in nature. But this is something that I think is emerging as a theme in a lot of literature right now. Not just my own work, but the number of times that precipitation whiplash or hydroclimate whiplash has been used in literature in the last 3 or 4 years has increased dramatically, and I've yet to see any papers suggesting that it's decreasing. So that's all I'll say about that for the moment. All right. I'm just going to look at 1 or 2 more questions here and then perhaps call it an hour. Let's see. Question from Zepp about California, Nevada, and Arizona just formally agreed to reduce draws in the Colorado River by 13%. Do you think that will be enough to keep the watershed at sustainable levels? Well, honestly, I have no idea. In the long run, the answer is probably not. For this year, well, it's probably enough simply because we got lucky with a pretty good snowpack, ranging from decent to great snowpack at different parts in the lower Colorado Basin. So it probably is enough to get us through this year, because the crisis has abated a little bit, somewhat by luck. Long term, probably not. My hope is that the relatively good snow year this year in the Colorado Basin doesn't distract the folks who really need to get it together to solve this problem in the long term, because we got a reprieve this year does not mean we will get one indefinitely. Although I guess if we get a strong El Nino event this coming winter, that might raise the odds of another at least decent year again next year. So maybe we've gotten a bit of a reprieve for a few years to give us a few years to work this out. That might be the optimistic way of looking at this. All right, this is the first time I've ever seen any spam in the comments section, so I'm actually reporting that a little bit, but yeah, let's see if there's any other questions here coming in. So I think I've gotten through most of what I'd like to answer today. Something just came in from Mason about thoughts on AI and weather forecasting and large-scale analyses. Yeah, that might be a better topic for another day. In fact, I may end up bringing someone in. That may be the topic of one of the next recorded conversations, actually, the ones that I don't do live. I've only done one of these so far, which was focused on the really interesting work by some scientists at Columbia University on the extraordinary heat wave in the Pacific Northwest in June 2021, and the role of climate change and sort of how we more broadly think about, as climate scientists, understanding extreme events that our models don't always predict very well. So what happens when the unexpected happens, and what do we infer about how the climate system is changing? I might actually add a link to that recorded conversation to the recorded version of this live session, so that folks who haven't had a chance to check that out can do that today, since I think it's hasn't gotten as much viewership as I had hoped initially, but I think there's some really interesting conversations embedded in that, and I would like to do more of those kinds of conversations. They do take considerably more time and effort, since I've got to wrangle very busy people, very busy, interesting people who have insightful things to say about topics, and then edit it, bring it all together. So it takes more effort, but it is something I will continue to do periodically. Again, as I mentioned, there's only that one up there. I'll put a link in the recorded version of this, or if you're just listening live right now, you can find it in the video section on the page. But I do think there's an interesting question for how AI and machine learning methods are getting used in earth science and in atmospheric prediction in particular, and really earth system prediction, because I think if we want to do some of these things right, we really need to be thinking about the Earth system as sort of this unified, set of interacting systems between the atmosphere, the ocean, the cryosphere, the biosphere, the land surface, and all that. And that, there's a lot of use and misuse of AI in this space. I do think there are some promising uses of it and some very unpromising uses of it. And I think a lot of the investment has been focused on the very unpromising aspects of it. So that results in some interesting conversations about resource allocation and the AI bubble, as some folks have argued. The great irony here is I think there is a lot of potential for it when wielded properly, but I'm not so sure it has been wielded properly in a lot of settings so far. So I do think that's a good topic of conversation. Probably not a good topic of conversation in the few minutes we have remaining today, but I do think that would be a good thing to talk about, and I may be able to bring a couple of interesting folks on for a recorded talk on that topic maybe later this year. Let's see here. I think that a couple of comments actually about folks who didn't realize that they could that I would be reading the chat live during these events to ask questions. So I think that would be a good thing to emphasize at the beginning of these conversations. That's a good reminder. I'll try and do that in the future. All right. Well, I think I'm going to call it an hour, even though we're a few minutes early. I think we got some good questions in. Next session, will probably be sometime next week. We'll see what's going on in the world, whether or not there's going to be a scheduled topic, or when things are quiet, I may do these open-ended conversations somewhat more commonly, since I know there's folks who have questions that aren't necessarily related to the topics that I've proposed in some of these conversations, so it's a good opportunity to get to that. And yes, I'll, as I mentioned, I'll put that link. I'll attach it to this video once it's done uploading, and you can check out that conversation with my colleagues at Columbia University on specifically that 2021 heat wave in the Pacific Northwest, and more generally about how we think about record-shattering extremes that are potentially paradigm shifting in terms of how we think about the dynamics of a warming world. All right, thanks for the good questions, everyone, and I think I'm going to close this one, but I'll